Okay, sorry about that. The free version of this program only allows you for a 10-minute screencast, so I'm gonna kind of try to go a little bit quicker here. So, as I was saying, y equals 2x was their first idea, and we know that that's not going to work because they start the same place. Y equals 2x plus 5 was the next idea. What's good about this, students? Oh, they cross paths. But like I said, this shows that the ant has a head start and they're going in the same direction. But as we know, they're not going in the same direction. They're coming from opposite directions and then crossing paths. So one student even got something like this, where they got the correct speed. They realized it would have to have a negative slope, but then it still wasn't crossing. But very few students did it that way. So how did students solve this? Okay, and the curriculum anticipates methods, and one of their methods is that a method that none of my students did, which is in 2.5 seconds, the other the ant must be going 2 centimeters per second. So 2.5 times 2 is 5, which means 10 plus 5 is 15, which tells you the starting point is 15 and it goes through that. That is not how students did it. The most popular method was students went back in time. If they see that in 2.5 seconds they cross at 10 centimeters, well, they said, well, if you take away a second, then it would be 2 centimeters further away, which means we're not going to take away 2 here, we're going to add 2. So they got that point, which, as we can see, is at 1.5 seconds, the ant would be 12 centimeters from where the ladybug started. That was the most common method. Another student said, well, if they go 2 centimeters every 1 second, how far do they go every half second? Which means 1 centimeter every half second. So they, instead of going back 1 centimeter here, they went back half a centimeter, which means they only went up 1 centimeter and they got 211. But as you can see, if you do this underneath the document camera on the paper copy of the student task statements, they'll see that these align. Then they can use their ruler or continue the steps all the way back to get the correct equation uh, of a line that looks like that, and that's what we want. Um, Now, then the students need to write an equation. So some of the students get it, but not a lot of them fully get it. But we go back to the first equation we wrote. Okay, they know that a proportional relationship starts with the origin, so we can write y equals kx. Students, is this green line, is the ant a proportional relationship? Like, no. And they're like, why not? Oh, well, it doesn't start at 0, 0. It starts at 0, 15. And so automatically, then we know we can't use y equals kx, so we have to use what, students? Oh, we got to use y equals mx plus b. So, very important equation of 8th grade. And the very first thing they can figure out is that starting point of 15. We know that's the y-intercept, that's the b value. So the students, they figure that part out already. So we know that the b value is going to be 15. And then what do we know about the slope, students? Oh, well, it's going to be a negative slope because it's going to decrease. It has to intersect it at 2.510. And so what's the slope going to be? Well, if the other person's slope was 4 for 4 centimeters a second, this person's going to be 2, but negative 2. So then they figure that out and they get y equals negative 2 for the slope, and they get y equals negative 2x plus 15. Also, some of the students will write it like y equals 15 minus 2x. I tell the students, write it in the way that makes the most sense to you. It starts at 15 and decreases by 2, or do you like starting at positive 15 and then it also having a slope of negative 2, so negative 2x plus 15? And I say use whichever way makes the most sense to you. So that basically talks about how incorrect answers, there's value in them, and they're leading students towards the rightness, and wanted to value let students, and I didn't call out the students' names who did it the wrong way. I just said, students in this class and other classes did it this way at first, and valuing, what makes sense about their ideas. And so finally, from there, that's only the first activity, and so that's like only a 10 to 15 minute activity. Then they're on to this one, a close race, and in this one they are graphing Elena and Jada in a bike race, and Jada is given in the table, so they graph that, and then Elena is just given as her rate, a steady 6 meters per second, and they have to graph both Elena and Jada on the same axes. So this assesses students' ability to scale graphs as well as plot the points correctly. The main idea that I want to get through to students here in the synthesis is if we see that our time values are in 6 and 9 are multiples of 3, we want to scale by threes. If we see 36 and 54, they're multiples of 6 or 9. We can go by 9s or we can go by 6s to make our life easier. Preferably by 9s because then we can fit up to 100 meters. So we also have to think about the length of the race there. Then students, they kind of like figure out, oh, well, they're the same. So it's the same graph, which is the main point of the lesson of that activity. So as you can see, the goal is that they can see that that's infinitely many solutions. So if we go back to the lesson plan, we can see when we're synthesizing that they're both y equals 6x or y equals 6t, but they have infinite solutions, but they have to be solutions to that equation of y equals 6x. Finally, then we're on to the lesson synthesis, and from there we have our animated questions here. So here it does say, it gives them this. A line goes through the point 2,5 and has a slope of 1.5. What is an equation of this line? So this is your opportunity where there is some direct instruction. I didn't ask them the questions. I just had this grid on my white book, those dry erase boards, and I literally just plotted a point at 2.5, and I said, well, 1.5, that's like 1.5, right? Oh, what's 1.5 as a single fraction? Oh, it's 3/2. And then I referred to my slope anchor chart where it says slope is vertical over horizontal, and from there we just went up 3/2, plotted another point, and connected it. And then plotted another y-intercept of 0, 10 that also goes to that point, and we wrote an equation of both lines, and that the fact that 2,5 was a solution to both lines, and it's the point of intersection. So that last piece is just synthesizing, y equals mx plus b, and it's synthesizing when a point is where two lines cross, that point of intersection is a solution to both equations of the lines there. And I'm finally I really, really, really love the cool down here, which is something I spent some time on in the next day. I really absolutely love it. It's called Saving Cash. And this one has Andre and Noah saving money. And it tells you what Andre started with and what Noah started with and how much they're depositing each week. And the graph here corresponds to this equation. And they have to plot Andre's savings and write the equation and interpret what that intersection point means. So I spent a lot of time underneath the document camera the next day on this one because it's there's a whole video I can make about that. But the whole point is I asked them, how does this equation show up on this graph first, which is not part of the question, just to get them seeing how the equation is related to the graph, and then calling on students who plotted the first point correctly and how they got the next point, and then really interpreting what that 540 means. In 5 weeks, they both have $40. Not just the intersection is when they have the same amount of money. It's actually the time as well as the money on them. And that's all I have to say about that. Thanks for listening. Hopefully it was helpful. In summary, notice and wonder, I would do the Google Docs, type them up. Also, when you're synthesizing your lessons or your activities, make sure you're honoring what people tried that didn't work, because as we know, some students are just not very hesitant to even try anything at all if it's not the right answer first.